Hello and welcome, people of the internet and programming enthusiasts. In this video, I'll show you how to turn 5 lines of class code into one with no magic, just data classes. So what exactly is a data class? In simple terms, it's a Python decorator that automatically adds common methods to your class like init, wrapper, and eq based on the fields you define. And the result, you end up with a class that's shorter, cleaner, and less error-prone. We can still access these common methods without having them defined explicitly. Here is a typical example. Let's say you wanted to represent a user as a class and store their name and age. You also want a string representation of this class and a way of comparing instances of that class that would look something like this, which in this case is a lot of code and accomplishes very little. Now, if we instead used a data class, we can replace a whole bunch of boilerplate code with a few clean lines of code. And all we needed to do was use a single method, decorator. By using a data class, Python generates a full constructor, string representation, and support for object comparison. The biggest benefit is the simplicity. You define the data your class needs to hold, and Python handles everything else. Data classes are optimized for data models, configurations, or storing state. By using data classes, you cut out a lot of boilerplate, which means less bugs, easier testing, and faster development. Let's try something basic and create a product class with an ID, name, and price for this product. We can provide type hints for these attributes for static analysis. Let's create a new instance of this product and output it. If we want it as a dictionary, we can just import as dict and output it as a dictionary. Now let's look at some of the more powerful features of data classes. Default values. You can add default values directly like this. This gives you a class where age defaults to 18 unless specified. If we want immutability, we can just add the frozen keyword argument and set it to true. Let's create a data class for a configuration that stores something like API keys and create an instance of this data class. Now, if we try change our API key after creation, Python will throw an error. Perfect for things like configuration where state should not change. Field customization. Sometimes we want more control, like hiding a field or using a mutable data structure like a list. Let's modify our product data class by using a default factory and disabling a string representation of our secret field. Default factory is how you safely assign mutable defaults like lists or dicts. Setting wrapper to false means that the secret attribute will not show when we print the object. Post-initialization logic. As discussed previously, Python handles the constructor for a data class, but if you still need to run additional logic after the already baked in init, we can use post-init. Let's use post-init to capitalize the first name of a person in our person data class. Post-init allows us to access the attributes of the data class in the same way init does. Post-init is a fantastic tool for data normalization or some simple validation, but it is simply a supplement and not a replacement for init. Now let's discuss some caveats. This is something we discussed earlier as part of field customization. You may be tempted to assign mutable values directly, like assigning a list property to an empty list. This is incorrect, and you must make use of the default factory keyword argument unless you want to introduce some strange behavior, like having every instance of that data class share the same list. Secondly, data classes are not intended for complex behavior. They are meant for data, as the name would imply, and are best suited for data representation, such as a row from a database, a configuration object from a JSON or YAML file, or an API schema. This is a good example of how a data class can be used to read a JSON config file and store it as a data class to be accessed at a later stage. You simply read the JSON file like a regular text file extract the contents of that file and map it to the structure of the data class itself. If we output this config, you can see the config displayed, and we can access all attributes of that configuration by using dot notation. Let's demonstrate representing an API response as a data class. We will be looking at the board API random activity endpoint, which gives us a random activity we can do when we are bored with some other data along with it. A response looks like this as JSON. We can represent this response as a single data class. We can use Python built-in types for type hints, which correspond to the data type of the field. Now we can do our request to the endpoint and add that data directly to the data class. We can use the double asterisk operator, also known as dictionary unpacking, to unpack the JSON as keyword arguments to the data class. Now we can write some print statements to output the data. Notice how we can access the attributes or fields of the data class using dot notation instead of bracket notation. This gives us improved readability, auto-completion, a more compact syntax, and type hints. Now you know almost everything there is to know about data classes. There is a bit more to it than this, but I trust you will actually read the documentation before attempting this on your own. Unfortunately, that's all there is for today. Thank you very much for watching. If you enjoyed the video, please remember to like and subscribe. As usual, I will leave a GitHub link in the description for you to have a look at the code. Until next time, take care and goodbye.